Good day, students. Welcome to mathgoodserve.com. And this clip we're going to be going over how to find limits at infinity. We're going to be taking a look at polynomials, rationals, and quotient of radicals. Alright, to get started, we're going to be going over the procedure that will be guiding our problem solving process, okay? Alright, so we're going to be taking a look at three cases. And these cases are determined by how the degree of the numerator compares to the degree of the denominator. Okay? So case number one, we have top heavy. Top heavy is a case where the degree of the numerator is greater than the degree of the denominator. Okay? When you have a top heavy scenario, your limit is going to be either positive or negative infinity. In order to determine exactly what the sign of the result is, you will have to substitute to find out. Substitute to find out. Okay, for example, let's say you want to find the limit as x approaches infinity of 2x squared over x. Now this is top heavy. Do you see why it is top heavy? Because the degree of the numerator is 2 and the degree of the denominator is 1. The numerator has a greater degree, so it's going to be plus or minus infinity just by inspection. And when you plug in infinity in the reduced form, which is 2x, you will end up with infinity. So you have top heavy. How about if the degrees of the numerator and the denominator are the same? We're going to call that equal weights. For that, your answer will be determined by simply dividing the leading coefficients. Okay, so you can divide leading coefficients or divide leading terms. You will still end up with the same answer. So divide leading coefficients. For example, let's say you want to find the limit as x approaches infinity of 3x to the third over 5x to the third. Now if you compare the degree of the numerator and the denominator with each other, you'll find out that they have equal degrees. So that's what I call equal weights. So in that case, all you just have to do is divide the leading coefficients, because at infinity these two will basically cancel each other out, and your answer will be 3 over 5. And then we have top heavy equal weights. The last case is bottom heavy. So bottom heavy, as you would expect, is a scenario where the degree of the denominator is greater than the degree of the numerator. In that case, your answer is always going to be 0. Alright, so for example, let's say you want to find the limit as x approaches infinity of x squared over x to the 10th power. You can see that this is bottom heavy because the degree of the denominator is greater than the degree of the numerator, and your limit is automatically going to be 0. Alright, let's take a look at some examples. The instructions are for us to evaluate the given limits. Question number 1. Oh, and before we start, just an acronym that you can use to remember this process is called TIBO. So let's go ahead and take a look at that real quick. So we have top heavy, T is going to be plus or minus infinity. Equal weight, you're going to divide by 0. And then bottom heavy, I'm sorry, you divide by the leading coefficient. And then bottom heavy, your limit is always going to be 0. Okay, so just remember T-I-E D-B-O, TIBO. Okay, so top heavy plus or minus infinity, equal weight, you divide leading coefficients, and bottom heavy, your limit is going to be 0. Alright, so this is applies only to rational functions and the quotient of radicals. When you're dealing with the quotient of exponential functions or logarithmic functions, there's a totally different approach for that. Alright, so let's take a look at the first example. We're to find the limit as x approaches negative infinity of x to the fifth minus 3x to the third plus x plus 3. Okay, so for this one, we can clearly see that it's a top-heavy scenario. Okay, let's write it. This is a top-heavy scenario. How do we know that this is top-heavy? Well, it is because this polynomial function can be written as a rational function. Okay, it can be written as that divided by the constant 1. So what is the degree of a constant? The degree of a constant is always 0, right? Because x to the 0 is 1. So let's take a look at it. If we write down our acronym to help us remember how to do this, typo. Which case are we looking at here? We're looking at top heavy, right? So if you have top heavy, it's plus or minus infinity. Now, in order for us to determine what it is, what we're going to do is we're going to take the leading term in the numerator, which is x to the fifth, with its sign, and the leading term in the denominator, which is just 1, or x to the fifth. And then we're going to substitute to see what the answer is. So this reduces to limit as x approaches negative infinity of x to the fifth divided by 1x to the 0th power. This is because in the numerator, the fastest growing term is the one that influences the limit, and in the denominator, the same applies. So here we're going to substitute. X to the 0 is 1, so we don't have to bother with that. We're just going to take a look at negative infinity raised to the fifth power divided by 1, because x to the 0 is 1. Now remember, this is an odd function, so if you raise negative infinity to the odd power, the sign remains. You're going to have negative infinity as your final answer. Alright, let's take a look at another example. Question number 2. What if we want to find the limit as x approaches negative infinity of negative x minus 3 divided by x squared plus x plus 1. Now, let's take a look at this situation that we have right here. So is this top heavy, bottom heavy, or is it equal weight? That's the question. So if we can classify how the degree of the numerator and the denominator polynomials relate, then we can easily determine what the answer is. Alrighty, so let's go ahead and write down the acronym to remind us how to do it. Typo. Okay, so top heavy is plus or minus infinity. Equal weight is you divide leading coefficients, and bottom heavy is 0. So what we'll do is we'll take a look at the degree of the numerator, the leading term, which is negative x to the first. So the degree of the numerator is 1. And then the degree of the denominator is 2. So what does that tell us? It tells us that this is bottom heavy. This is a bottom heavy scenario. Okay, just like the other one that we did was top heavy, this is bottom heavy. Now what is the limit as x approaches plus or minus infinity of bottom heavy rational functions like this? BO, right? BO basically tells us that the limit is going to be 0. So this one is simply going to be 0. Let's simplify. So this is the limit as x approaches negative infinity of negative x divided by x squared. And then if you see that the degree of the denominator is greater, it's automatically going to be 0. Alright, let's take a look at another example. In this case, we're going to look at a radical scenario, okay, where we have the radical of two polynomials. So we limit as x approaches negative infinity of the third root of x squared plus 2 divided by x squared plus 4. Okay, so how do we attack a problem like this? So even though the polynomials, both of them are, we're taking the cube root of both of them, what we're still going to do is we're going to go into the radicand and examine the polynomials that are there and ask ourselves, how do the degrees compare? Okay, is it top heavy, which would take us to plus or minus infinity? Is it equal weight, which will just have us divide leading coefficients? Or is it bottom heavy, which will give us 0? So that's the question. Alright, so let's take a look at this right here. So if you compare the degree of the numerator to the denominator, what do you notice? They both have the same degree. So it's going to be equal weight. Okay, so we're going to be dividing. Now, something to consider in this case is that we have a cube root on the outside, so that will have to be considered too. Alrighty, so this problem reduces to limit as x approaches negative infinity of the cube root of 1x squared divided by 1x squared. Alrighty. Now, when you divide leading coefficients, what you're going to have here is you're going to have the limit as x approaches negative infinity. These x squares cancel out of the cube root of 1 over 1. Okay? And then when you simplify that, that's simply going to be the limit as x approaches negative infinity of 1 over 1 is just 1, right? The cube root of 1, and your answer is simply going to be 1. Okay? So this just helps us to see that when you are applying Tybal to a scenario where you have a radical, you will have to apply that operation to whatever term that you are considering the limit of. In this particular case, the radical applied to the numerator and the denominator, so we apply that. In certain problems, it might just be the numerator, as you will see in question number 5. Okay, so the answer to number 3 is 1. Alright, let's take a look at question number 4. So for this one, we are looking at let's say we're to find the limit as x approaches negative infinity of 2x to the 4th power divided by 3x squared minus 4. Okay. Alright, so for this one, let's go ahead and compare the degree of the numerator and the denominator. Basically, we're looking at the degrees of the leading terms for the numerator and the denominator. So if we take a look at this right here, we have only one term in the numerator, the quartic monomial 2x to the 4th, and then the leading term in the denominator is the 3x squared component. Alright, so if you take a look at this, you can clearly see that it is top heavy. So let's write out typo again. We're looking at a top heavy scenario here because the degree of the numerator, 2x to the 4th, is bigger than the degree of the denominator, 3x squared. Okay, so if we extract those, this limit is simply going to be the limit as x approaches negative infinity of 2x to the 4th over 3x squared. Now, we know what the answer is going to be. Because it's top heavy, it's either going to be plus or minus infinity. Alright? So in order to determine exactly what the answer is, we just have to substitute negative infinity here just to find out what the answer is. Alright, so before we substitute, let's go ahead and simplify that completely first. So x squared goes here 1. Subtract 2 from that. This becomes a limit as x approaches negative infinity of 2x squared over 3. You can clearly see that the numerator has a greater degree. It will be growing much faster than the denominator at negative infinity. And then we can just substitute. We have 2 times negative infinity square divided by 3. And then if we simplify that, we have 2 times negative infinity square, since this is an even function, will be times infinity divided by 3. Your final answer is going to be infinity. Okay? So that is the answer to question number 4. All right, let's take a look at one more example. Now, what if you were to find the limit as x approaches negative infinity of the square root of 3x squared plus 1 divided by x minus 2. Okay? Alright, so for this one, let's go ahead and compare the degree of the numerator to the degree of the denominator. Alright, so that will tell us what case we are looking at here. So in the numerator, we have a square root of 3x squared plus 1. And in the denominator, we have x minus 2. Alright, so what case are we looking at here? Is it top heavy, which is plus or minus infinity? Is it equal weight, which will involve us dividing leading coefficients? Or is it bottom heavy, which would just be 0? Alright, so if you look at this just by observing, you might think it's top heavy, but we have a square root component here. The square root applies only to just the numerator. So we're going to extract these two together, and then in the denominator, we're just going to look at x. Alright, so do you see what case we have here? So let's extract it out. So we have limit as x approaches negative infinity of the square root, that's the fastest growing term in the numerator, is 3x squared. We're taking the square root of that divided by x. Let's simplify it a little bit more. This becomes the limit as x approaches negative infinity. We can take the square root of these two. If you remember the property of radical, if you take the square root of xy, it's the same thing as the square root of x times the square root of y. You can distribute the square root amongst the factors of the radicand, if you can write them as factors. Anyway, so here we have, what do we have? It's going to be the square root of 3 times the square root of x squared. Okay. The denominator needs no simplification, which is just x. Now, alright, so that's going to give us the limit as x approaches negative infinity of the square root of 3. If you take the square root of x squared, that's going to be absolute value of x divided by x. Okay, so you can see that the square roots reduce the degree of the numerator polynomial by dividing it by 2. Just cut it in half, okay? So that's what square roots do. Okay, so what we have here, we'll just plug in negative infinity, and then we're going to see what the answer is going to be. So we have, alright, so before we can cancel that out, we have the absolute value bars to consider here. So this becomes the limit as x approaches negative infinity of I'm going to put the x in front. If we drop the absolute value bars, we will have plus or minus x root 3, and then that divided by x. Now, if we take a look at the directionality here, we're going to negative infinity. We're going to the left side. So the sign of this plus or minus is going to be negative. Okay, so had it been we're going to infinity, this would be positive. If we're going to negative infinity, that's going to be negative. So this limit is going to become the limit as x approaches negative infinity of just negative x, because we're going to negative infinity in the left direction, negative x root 3 over x. Alright? Now let's go ahead and reduce. We can now reduce this x, and this one divides out, and that gives us the limit. Let's make that thinner. The limit as x approaches negative infinity of negative root 3 over 1, or just negative root 3, and then you can clearly see that the final answer is negative root 3. Okay? So what made it slightly complicated here is because we're taking the square root of an even of a term with an even power. So whenever you take in the even root of a term with an even power, as long as it simplifies, you will have to insert the absolute value components, because when you square, you raise a negative number to an even power, you're going to get positive, and if you raise a positive number to an even power, you get positive also. So you have to consider both positive and negative. All right, so there goes the answer to question number 5. Alrighty, so how well did you master the contents of this presentation? To demonstrate mastery, we'd like you to try out the following problems. So instructions are the same as before. You're to find or evaluate each limit, evaluate the given limits. For question 1, what if you were to find the limit as x approaches negative infinity of negative x squared minus 2x plus 4. Question 2, what if you're to find the limit as x approaches negative infinity of negative x to the 4th divided by 4x squared plus 4. Number 3, what if you're to find the limit as x approaches negative infinity of the of the square root of 4x squared plus 2 divided by 3x plus 1. Question 4, what if you're to find the limit as x approaches negative infinity of x divided by x squared plus 2x plus 2. And then number 5, what if you're to find the limit as x approaches infinity of 4x over the square root of the square root of x squared plus 2. Alright, so what we'd like you to do at this time is pause this video presentation and try out these problems. When you're done, just click back on the playback button, and then you are going to see what the answers are. Okay, hopefully you had a chance to try out these problems. Let's go ahead and take a look at the answers. For question number 1, the limit is negative infinity. For question 2, the answer is negative infinity. For question 3, this is negative 2/3. And then for question 4, 0. And then for question 5, the answer is 4. Thanks so much for taking the time to watch this presentation. Let us know what you think. If you found the contents of this tutorial helpful in your studies of limits, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other calculus tutorials to help you do well in your calculus class. If you have any questions, comments, special requests For math tutorials, just post it in the comment section below and we'll be more than glad to assist. More support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.